Hello, hello. Let's go ahead and get started here. We are covering P8, solving basic equations. Take notes, hit the closed captioning button if you need it, and get ready to text me if you have any questions. And don't forget, if you need help with any of the assignments or any of the topics, make sure you take advantage of the NetTutor link that is on our Canvas page. Okay, so just click on NetTutor and then you can navigate through it. It's not just tutoring for math, it's for all different subjects. So if you find yourself struggling, make sure you get the help that you need ASAP. Okay, take notes. Solving basic equations. All right, so let's start off with some linear equations. I'm pretty sure you're proficient at solving these. Okay, so linear equations, they look like this. Solve 7x minus 4 equals 3x plus 8. Okay, and so what happens here is I'm going to go ahead and write the problem down here so that we don't lose the original problem in the process. Okay, so just remember whatever you do to one side, you have to do to the other. Here we have x's on both sides. So I need to cancel one of these x terms, and it doesn't matter which one. You could subtract 7x on both sides, or you could subtract 3x on both sides. It doesn't matter. At the very end, everyone will get the same answer if they do the math correctly. Okay, so I'm going to go ahead and choose to subtract 3x on both sides. Okay, and when I do that, I end up with 4x minus 4 equals 8. And then here, I'm going to go ahead and work on getting that term with the x by itself. So I'm going to go ahead and add 4 to both sides, and that will get the 4x by itself over here, and 12 on that side. And then this is multiplication by 4, 4 times x. And so we are going to do the inverse operation of multiplication, which is division. So I am going to divide both sides by 4. 4 divided by 4 is 1. So we end up with 1x on the left-hand side. And over here, I get 3. X equals 3. Okay. And you can always go back and check your answers by plugging in the 3 into the original problem up here and make sure that you do get an equality. Okay, let's take a look at this one where we have fractions, because sometimes students get thrown off because we have fractions involved. So we have x over 6 plus 2 over 3 equals 3 over 4x. Okay, so over here, this is like, see how we have the 3/4 times x? So this is kind of like 1 over 6 times x. Okay. Okay, so here for these equations where we have fractions, we're going to go ahead and clear our fractions, get rid of our denominators. Okay, let me go ahead and write the problem down here. Okay, so we are going to clear our fractions, and we do that by multiplying all the terms, whether they're fractions or not fractions, but you're going to go ahead and multiply all the terms on both sides by the LCD. Okay, and in this case, our denominators are 6, 3, and 4, so our LCD is going to be 12. Okay, so this is what we do when we have fractions. All right, so I'm going to go ahead and multiply everything by 12. And when I do that, the fractions disappear. I get 2x there. I get 8 there. And I get 9x over here. Okay, so when you clear your fractions, now this becomes something a little more familiar. And you can go ahead and solve this as usual. The way you solve this, you get the x by itself. We have x's on both sides, so we need to cancel one of them. So we could either subtract 2x on both sides, or we could subtract 9x. So I will choose to subtract 2x. Doesn't matter. And so I get 8 equals 7x. And then you can divide both sides by 7. 7 divided by 7 is 1. So we end up with 1x over there. And we get 8 over 7 on this side. Okay. But the key thing here is that when you have fractions, you can go ahead and clear your fractions. And you do that by multiplying all the terms, whether they are fractions or not, by the LCD. Okay. We're going to take a look at another equation where we have fractions, but it's different from this one, because if you notice here in this problem, all of our denominators are made up of just numbers. Okay. In this next example, we will have fractions, but our denominators will have numbers and variables. Okay, and we're going to go ahead and treat it the same. We're going to go ahead and clear the fractions, and we're going to multiply all the terms by the LCD. So the process is the same. The only thing that's going to be different is the very end. Here, because we have 6, 3, and 4 in the denominators, then our answer here will not affect the denominators. The answer that we get here will not cause us to have 0 in the denominator. So when we get our answer here, we don't have to check it. But when you have something like this, okay, so suppose that we are solving 2 plus 5 over x minus 4 equals x plus 1 over x minus 4. Here, we have variables in the denominator, so in this case, we do have to check our answer, because the answer that we get might cause the denominator to be 0. And if we have 0 in the denominator, then it's undefined. Okay? All right, so that's the only difference. At the very end, you need to check your answer. Okay, and I'm just going to leave room. I space this out because I know I'm going to be multiplying all the terms by the LCD. Okay, and here in this case, the LCD is x minus 4. So you can think of it as, okay, well, what do I need to multiply by to cancel the denominators? If I multiply by x minus 4, the denominators will cancel. Okay. All right, so I need to multiply everything by x minus 4. I have plenty of room on both sides. Okay, so over here, the x minus 4's cancel. And same thing here. Okay, so now I'm going to use the distributive property over here. Okay, and so I get 2x minus 8 plus 5 equals, on this side, I will have x plus 1. Okay, so then I go ahead and combine like terms, simplify this, and start my solving. So on the left-hand side, I have 2x minus 3 equals x plus 1. Okay, so all I did was combine the like terms, negative 8 and 5. And then now I can go ahead and solve as usual. So I'm going to go ahead and cancel one of my x's here because I have x's on both sides. So I'm going to subtract x here and here. All right, and so that will give me x minus 3 on the left-hand side and 1 on the right-hand side. Finishing up the solving process, add 3 to both sides. And we end up with x equals 4. Okay, so, and this is a perfect example as to why you need to check your answer. All right, we have x equals 4, right? Now, if you look at this previous example, no matter what x value we get here, it doesn't change the denominators here. So we don't have to worry about this x value creating a situation where it's undefined, where we have 0 in the denominator. Okay, but over here, we have x in the denominator. And so we have to worry about the type of answer that we get. And we can see here, we got x equals 4. However, when I plug that into the original problem here, when I plug 4 in for x, I get 4 minus 4, and that is 0. 0 in the denominator is undefined. So this answer that we get doesn't work. Okay, so this does not work. And so we have to say we have no solution. Okay, so that's the difference between these two problems where you have fractions. The process is the same. You still have to clear your fractions and then solve. The only difference is at the very end, for this type where you have x in the denominator, you do have to check your answer. Okay. All right, let's move on to a different type of equation. Let's take a look at power equations. Okay, so the power equation, and I'm going to use this funny looking x because it's not just the letter x, but it's whatever we have there. So maybe we have an x, maybe we have 2x plus 3, okay, whatever the expression is. Whatever that is to the nth power equals a has the following solution. Okay, so you would take this and you essentially will take the nth root of both sides to cancel the nth power. Okay, so it would be the nth root of a if n is odd. And then over here, if n is even, when you take that even root, you're going to actually have two answers, plus minus. Okay, so if n is even, so like if you're taking the square root, you'll do plus minus the square root. If you're doing the fourth root, you'll do plus minus the fourth root, etc. Okay, but if it's cube root, if you're taking the cube root of both sides, cube root, That's odd. Okay, so cube root, you're not going to do plus minus. You'll only have the one answer. Okay. And just for technicality, in this case, a is greater than or equal to 0, because if not, then we get something that is not real. We get something that is imaginary. Okay, so if n is even, so if you're taking the even root, so if n is even and a is negative, less than 0, there is no real solution. There is no real solution. That's when we get into complex numbers and you end up with imaginary. Okay. All right, so let's take a look at this example here. Let's go ahead and solve x squared minus 5 equals 0. Okay. All right, so I'm going to go ahead and rewrite the problem down here. Okay, so here this doesn't factor. That's not like difference of squares or anything like that. So one way to solve this, we can add 5 to both sides. Cancel that out. So we get x squared equals 5. And so this is how you get rid of these powers. So if that's a square, then you're going to be taking the square root. So let me go ahead and use a different color here. So if you need to cancel out that power 2, that square, then you will take the square root of both sides. But remember, if you're going to do an even root, you'll be taking the positive and negative answer. Okay? All right, so we get the x by itself equals plus minus the square root of 5. Okay? All right, and so if it asks you to write the answer separated by a comma, you can, because WebAssign is weird that way. So you can just say x equals 5, square root 5, and negative square root 5. Okay? Either one is fine with me, but sometimes WebAssign likes their answers entered a certain way. Okay, let's take a look at this one. Solve x minus 4, quantity squared equals 5. Okay, so we need to cancel out that square. So we will use the square root. And when we do the square root, we will have both a positive and a negative answer. Okay? All right, so we get x minus 4 equals plus or minus the square root of 5. And then we need to add this 4 to both sides. So x equals 4 plus or minus the square root of 5. So this is one way to write the answer. Again, if WebAssign wants you to write it to two separate answers separated by the comma, you can say 4 plus square root of 5, and the other one would be 4 minus the square root of 5. Okay. All right, and let's take a look at some higher powers. Let's take a look at this one. Let's go ahead and solve x cubed equals negative 8. Okay, so again, if you need to cancel out a power, then you use the root. So here this is power 3, so we won't use square root, we will use cube root. Okay, see how that works? So these guys cancel. And you end up with x equals, and this is odd, so we only have one answer, and that is going to be negative 2. Okay, it's negative 2 to the third power will give us negative 8. Okay, and let's take a look at this one. Let's go ahead and solve. 16 x to the fourth equals 81. All right, so I'm going to go ahead and divide both sides by 16. And then now I'm going to get rid of that power 4. So I will use the, not the square root, not the cube root, but the fourth root. And this is even. So when you take the fourth root here, you will get two answers, the positive and the negative. Okay. All right, so we end up with x equals plus or minus fourth root of 81, 3, fourth root of 16, 2. So we get x equals positive 3 halves and negative 3 halves. Okay. So you can say this. Okay, either way is fine with me. Okay, let's take a look at fraction powers. Okay, so what we're going to do here is if you have an exponent, a power that is a fraction, then what you're going to do to cancel it is use the reciprocal. Okay, which is, I guess, you can think of it as doing that here as well. We used the reciprocal of 2, which is 1/2, which is the square root. We use the reciprocal of 3, which is 1/3, which is the cube root. And the reciprocal of 4, which is 1/4, which is the fourth root. Okay? All right, so use the reciprocal of the power to cancel the fractional power. Okay, so let's take a look. Let's go ahead and solve 5 x to the 2/3 minus 2 equals 43. Okay, so I'm going to go ahead and rewrite the problem down here. All right, so I'm going to start with adding 2 to both sides. I get 45. And then I'm going to go ahead and divide both sides by 5. Cancel that out. And that's 9. Okay. All right, so right here, this is the part where you need to somehow cancel out that fraction power. And so this is where you can use the reciprocal. So you can raise this to the, not the 2/3, but the 3/2, both sides. Is what you do to one side, you do to the other. And remember, when you have a power to a power like this, you would multiply the powers and you end up with 6/6, which is 1. So x to the first power equals, and then this one here, you can think of it as this, and square root of 9 is 3 to the third power, and so x equals 27. Okay. Oh, I forgot. When we take the square root. Okay. So let's take a look. All right, so right here I did the square root, right? Took the square root. So that's plus minus. So it's plus minus. So it's plus minus. All right, and so here we need to check. Make sure that these work out. So let's go back to the original problem. Okay, let's check over here. All right, so let's check positive 27. Okay, so we have 5 times 27 to the 2/3 minus 2, and we want to know if we're going to get 43. So let's work this out. 5, this is like cube root of 27, so that's going to be 3 squared. And then this is 5 times 9, and that's 45 minus 2, and that's 43. Okay, so this one works. We do get 43. Let's check. Now let's go ahead and check x equals negative 27. All right, so 5 times negative 27 to the 2/3 minus 2. Okay. All right, so here we get 5 times cube root of negative 27 is negative 3. Negative 3 squared is 9. 45 minus 2 is 43. Okay, so they both work. So your answer is plus minus 27. Okay, let's see. All right, formulas. So that's how you deal with fraction exponents. You just use the reciprocal, as you can see right here. Okay, so you use the reciprocal power, and you'll end up with 1 because you get 6 over 6, which is 1. Okay, and that's what you're trying to do. Okay, let's go ahead and take a look at formulas. So when you're dealing with formulas, oftentimes you'll have more than one variable. And so you'll have to solve the equation sometimes for one of the variables. And it will be in terms of other variables. Okay, so let's take a look here. Okay, so let's take a look at this one. Area equals pi r. Let's do 2 pi r. Okay, here, hold on a second. Okay, so let's do circumference of a circle. Pi times d, right? So you have this here. Circumference is pi times the diameter, or 2 pi r. Okay, so let's solve for d. Okay, so you have this here formula, and you want to solve for d, which means you have the whole solving process is still the same. You still have to get that variable that you're solving for by itself. Okay, and so we see here that the d is not by itself. We have this multiplication by pi. Pi is like 3.14. So we need to undo this multiplication. So we're going to go ahead and do the inverse operation, which is divide. So we're going to go ahead and divide both sides by pi to get that d by itself. Okay, and we end up with c over pi equals d, and there's our solving for d. Okay, let's take a look at another one. Let's go ahead and solve for m. Capital M in this formula. Suppose we have f equals g times little m times big M over r squared. Okay, so we need to solve for capital M. All right, so let me go ahead and write this formula down over here. Okay, so we do have a fraction, so I'm going to go ahead and clear my fractions. I'm going to go ahead and multiply both sides by the LCD, which is r squared. Okay, so I'm going to go ahead and multiply both sides by r squared, and that will get rid of that part. Okay, so we are working our way to getting the capital M by itself. Multiplication is commutative, so I am going to go ahead and write the capital F first. It doesn't matter. Okay, so here we have the capital M. We are trying to get this by itself. We have multiplication by this lowercase m and multiplication by this capital G. So I want to undo those multiplications. So I will divide both sides. And I can take care of both of them at once. Okay, because they will cancel, and so will they. Okay, and so here I get M, capital M by itself, and it turns out that capital M is equal to F times R squared all over GM. Okay. All right, let's take a look at this last example. Let's solve for W in A equals 2 LW plus 2 WH plus 2 LH. Okay, so I'm going to go ahead and rewrite the problem down here. All right, so we are solving for W, and if you notice, we have W in this first term, and we also have W in this second term. Okay, so what I'm going to do is I will factor out the W so that I have only one W instead of two. Okay, so I am going to factor out the W from only the first two terms. So I get that. And this plus 2LH is still part of the problem. Okay. All right. So again, this allows me to have only one W as opposed to two. Now I can go ahead and start my solving. I want to work my way to getting this W all by itself. So I'm going to go ahead and subtract this term. Subtract 2LH from both sides. Okay, and then that will give me A minus 2LH equals W times 2L plus 2H. Okay, and now I want to get that W by itself. Getting this W by itself, so I will divide both sides by 2L plus 2H, because this is here a multiplication. So I will use division to undo this multiplication. And so all of this will cancel out with all of that. And we get the W all by itself. And we get A minus 2LH all over 2L plus 2H. Final answer. All right, so that is it. If you have any questions about any of this, make sure you text me or send me an email, or visit the tutoring center online by clicking on the NetTutor link that is on Canvas. So your homework for section P8 is going to be on page 59. And again, the chapter P assignments are optional. I want you guys to focus only on the problems that you feel like you need extra practice on. So negative, not negative, number 7 through 99, odd. All right, I will see you guys next time.